Just a quick intro about me. I work on AI ML systems, so kind of lower level than I think a lot of the things that typically discussed in these kinds of forums. I worked on a very central modeling system at Meta, and worked with hundreds of AI ML teams on their systems. And just to sort of entertain a discussion about AI ML systems, what you're looking at in front of you is a very common toy data set, Machine Learning 101, for classifying articles of clothing. It's modeled off of the MNIST handwritten digit data set. And the first message I want to give to you is that bigger models don't necessarily mean better performance. Your model is not necessarily your system. If you use GPT-4o Mini, try to classify this data set, you'll get about 81%, which is embarrassingly bad compared to just like the kind of computer science 101 models that you could use, which get 90 or 95% and run on a CPU. So the rule is basically that systems which are adapted to data almost always outperform systems that are not built tailored to that data. We say not your data, not your task. Your model is a compilation of your data. So when you look at large ML systems like social media ranking systems, how do they achieve the success that they have? They are adaptive to data. They take their sort of V0 state and the production interactions that users have, and then they retrain the system to be adaptive to recommend better and better videos to you. And you can do the same thing with your AI chat application, right? Your pre-trained model is only the start of your application. Your application space wrapper is only the start, and the interactions that the users drive with the system are your opportunities to improve it and to make it adaptive, to learn a domain in a way that a human really wouldn't be able to sort of hand program. So this is true for most kinds of AI ML systems. There isn't anything sort of prescriptive to say here about what you should or shouldn't do. I think that the message of AI ML that we should take coming off of the last 7 or so years is that AI ML practitioners should see themselves sort of like operations researchers. You just have a dizzying array of techniques that you can use. You have a system in front of you to optimize, and you should just be banging on it every way that you possibly could or know how, but just have in mind that the adaptation to data is a really important technique in your toolkit for doing so. If you limit yourself strictly to prompting, you're sort of relegating the techniques available within your system to sort of rule-based branching, and it becomes a sort of game of whack-a-mole. That works for like, a dozen or so feedback points or sort of breakages when your system is in production, but at scale, it really does not work. And like a really simple example of this, or where these kind of issues can be pernicious, is that when you take retrieval-based systems that are trained on web data, they get like 95% scores on retrieval for Wikipedia-style documents. You take the same data and you use, take the same system and use it for retrieval over legal documents, it gets horrifically bad, right? 49% is horrific in the machine learning world. If you were to just, at the end of every day, retrain your system on the data that it saw that day, it would do significantly better, right? Just by being self-adaptive in that way. So you need to see that as a thing in your toolkit rather than just the sort of deployment of the application proper. So big model providers want you to believe that doing this is hard and expensive because they want you to use your models. But the truth is that training has never been easier. The code is actually extremely available in open source libraries and examples. Hugging Face is one to call out, considering the venue. Data estates have never been cleaner. Snowflake and Databricks have led a significant charge there. So the availability of offline data in something like a data estate has never really been better. 3 or 4 years ago, actually, the data was often the blocker. And online data, the propagation of user interactions back into the application using using RL or training or whatever, these techniques have gotten really mature. So the message is, don't be afraid of, your fear of infrastructure, not necessarily code, could be the thing blocking you. All right, so we use Snowflake as a common analogy here. Before OLAP databases, you used to have to do infrastructure if you were trying to run a SQL query or do some sort of data processing that didn't fit on a single machine. You needed a team managing Hadoop clusters and conforming your queries to those clusters. After Snowflake, you really just need to know SQL, right? You take your SQL query, you throw it at Snowflake, you could command massive compute without really thinking about it. And that is just purely magic for the armies of people that know SQL that can now build really massive, sophisticated data systems. That is the magic of infrastructure. So the takeaway if you're an AI ML systems developer is focus on your infrastructure and how it creates optionality for you and how you attack your complex system. There are going to be places where prompting is the right answer. There are going to be places where adaptiveness to data is going to be the right answer. And you really need speed as you do that adaptation, and infrastructure equals speed. So if you're interested in these topics, feel free to reach out to me. Thank you.